Hello.
Hello, Mr. Ryan, right? Yeah, good. Okay, so we're going to talk about the longest palindrome. What's palindrome? What's palindrome? Can you give me an example?
Palindrome is like race car.
Yeah, race car.
Obviously.
So the string, like it's reverse version.
A, B, C,
is
D,
the
F,
same.
G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V,
What?
W, X, Y, Z, Y, X, W.
Okay, I see what you're doing. You put it A to Z and then backwards again, right? So basically, the string it's reverse. It's the same. Then it's palindrome. Okay. So in Python, how do we check a string S is a palindrome? Any idea? Look, the easiest way. Can you tell me the easiest way? Come on, Eric. I think you know this one. If you want to find out, there's a quick syntax in Python that allows us to. Yeah. So S equal S column minus one. Right? So basically, look what's this. Look here. This is from. The second is to. The third is step. Okay. So we're not giving any parameters from. So it starts from the 0. Not giving anything to the 2 parameters. So it goes to the end of it. So which is n and my n, right? And if there are n characters. And step minus 1 means reverse. So we can define, is palindrome S, and then we can just return S equals S column minus 1. So also you can do this. Is palindrome lambda function a short function without without a define? Yeah. Is palindrome equals lambda S, and then we can say S column minus 1 equal S. Okay, so this is the quick syntax. Otherwise, we can use the 2-pointer thing. Yeah? We have pointer from the left, from the right. We check if they're both characters at the index, if it's the same. If it's the same, then we keep moving until they meet in the middle. And that's a palindrome. Otherwise, it's not palindrome, right? Yeah. So we talk about that. The time complexity is O(n), right? Obviously, okay. So now I'm given a string, right? Look, A, B, B, A, B. What's the longest substring? Palindrome. What's the longest substring that is also palindrome? The substring continues. S continues.
A, B, 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 A. No, A, B, B, A.
Yeah, obviously, okay. So substring continues. Subsequent, which is not continuous, yeah? Substring continues.
B, A, B.
Okay, another example. A, B, C, D, B, C, B, A, B. Okay? Come on,
C.
what's the longest substring? What's the longest substring? What's the longest substring?
A, B, C, D, D, C, B, A.
A, B, C, D,
D,
C, B, A. Any more? Any more you can find?
B, A, whatever B.
Okay, how many of these? 1, 2, 3, 4, 5, 6. How many of these? 1, 2, 3, 4, 5, 6. 7, 8. Okay, so this is clearly longer. Right? So one question: if the whole string is a palindrome, then the longest substring, which is also the longest substring, right?
Which is
Yeah?
the whole thing.
Yeah. A, B, 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 A, C, C. What's the longest palindrome
The whole
substring?
thing.
The whole thing, exactly. Okay. So now, okay, so you understand, yeah? So substring continues. Usually when we solve this kind of problem, we need O(n) square, right? If there are n characters, yeah? And there are Cn2, Cn1, right? So why is that? Look, if the substring contains more than 1 character, then it's Cn2. If it contains only one character, because 1 character is also the substring, so it's Cn1. So if we add this together, Cn2 is n times n minus 1 divided by 2. Cn1 is n, obviously. So if we add up these two together, it will be n plus 1 divided by 2 if my math is correct, okay? So they are total, this number of substring, n plus 1 divided by 2. So if we want to prove for thingy, yeah? So it needs the O(n) square, right? Do you get it, Evan?
Yeah.
So how do we, if we're going to prove for this n square palindrome, so what's the overall time complexity of this algorithm? Look, we use O(n) square to prove for all the substrings, right? But for each substring, we want to check if it's a palindrome. That's going to take O(n) time, right? So what's the time complexity? Anybody?
O(n) cubic.
Where down O(n) cubic, yeah? Because O(n) square You understand, yeah? For on square to brute force all the substring. We're talking about all, yeah?
It's
Eric, do you mean,
cubic.
Eric, this bit. This is the total number of the substring. CN2 means that if the substring contains more than one character. CN1 means that if the substring contains one character, okay? Okay, so we can do this, okay? But we can optimize this a little bit. It's ON cubic, yeah? It's ON cubic. And think, how do we make it ON squared? One easy way would be to make the palindrome check O1, yeah? But how do we make ON palindrome check O1? We can compute, we can calculate it in advance and put it in the table, right? So we can just look it up, right? Alright? Then that will make the check O1, right? Okay? So now let's do this brute force for example, yeah? Long case. Eric, come. Ryan,
What?
too noisy.
I'm not.
S, okay? N equals length S, okay? So the easiest way, right? The easiest way. So we want to store the left and right would be the left and the right index of the longest palindrome, which is to -1 maybe, okay, maybe better. For I in range N, come on, this is the brute force. For J in range I to the N, right? Look, we have seen this before a long time, right, Eric? This is the classic way to brute force a substring, right? So we start with I, which is the left index, J is the right index, and then the current string will be what? The substring current string will be S I up to J, right? Up to J. And then we just have to check if the C minus -1 equals C, then also we have to check if the J minus I is bigger, the length is bigger than R minus L, then we record the R equals I, R equals J, right? And then return S
That's number one.
L R plus 1, right? So this is the brute force, right?
Yeah.
Come complexity.
N square cubic.
Cubic. Here. This is, look, this is N.
That's
ON.
number one.
So this is ON. And then, okay, so we need to check this. This is ON, right? So ON times ON times ON. So the thing is that this is slow. We don't need to, every time we do this palindrome check, it takes time, right? It takes time. So we need to find out a way to store these results so we can get it in ON or O1 constant, right? Okay, one optimization is that, look, that even this is ON cubic, okay? Even this is ON cubic, we can still optimize this a little bit. So how can we optimize? We can reverse the order of the J index, right? So instead from I to N, look here, this is I, the index, the characters goes this direction, from 0 to N minus 1. J at the beginning will be from the J will be from I to N. If we reverse this, if we reverse the J from this side, from N minus 1 to this side, okay? So what happened? If we reverse this bit, N minus 1 up to I, we reverse J from N minus 1 to I, right? And minus 1, which is the step backwards. Then if we found the palindrome, then we can just break, right? Because there's no point to keep finding it, right? Keep finding it. Okay, what I'm saying is that, look, if we found a palindrome, if I, we determine this I, and then with J, we go reverse direction. If we found this is a palindrome, then we don't need to keep moving the J towards the I, right? Because if we already found this is a palindrome, if we keep doing that, the palindrome, the substring will be shorter. Do you get it? So there is no point to iterate the J, right? So we can break. What's break in the for loop? What's the break? What happened? What happened with the for break up here?
It breaks it.
Breaks it. So for you will break whatever J here, you will break, and then you will here the I will be increment here next one, right? So that's it. So we can optimize this by caching catching the palindrome check, right? So we don't want to calculate if this substring is a palindrome in real time. So we can use the, we can pre-calculate this table. Let's say if we have this f function, fij, so that will tell us if the string s substring I to j including the j index, if it's a palindrome, right? So then we can replace, we can replace this check, yeah? We can replace this check. We can replace this check here. This is expensive, right? We want to replace this check, yeah? First of all, we can define this function, yeah? Define fij. Fij, it means that if si to j, the index, if it's a palindrome, right? So if it's equal, so there are two base cases. Fii, if a single character, this is also a palindrome, right? This is a palindrome. How about fi and I plus 1, right? Yeah, fi and I plus 1 equals si equal as I plus 1, right? Yeah? So basically what it means is that, well, if there's only one single character is a palindrome, right? Yeah? Two single character, they need to be the same. This is two base cases, right? And otherwise, fij equals fi plus 1 j minus 1 and si equal sj, right? So we might want to put this in the front, yeah? Yeah? So Fij equals si equals sj. If these two characters, so basically look, a something a, okay? So look, fi, here is I, here is j. Fij, if it's equal, look, a equals a, then it equals fi plus 1, this is j minus 1, right? What kind of equivalent is this? What? Not quite. I mean, look, if I tell you that there's something missing here.
Cash.
Yeah, cache, yes. What's this? In what equivalent do you put the cache?
Top down.
Top-down dynamic programming, yeah.
Minimization.
Exactly, yeah, exactly. So look, so if we want to know Fij, if it's the substring from index I to j, if it's a palindrome, then we have to check the index, the characters index si and sj. If they are equal, then also fi plus 1 j minus 1 needs to be a palindrome, right? Needs to be true, right? Easily by putting a cache, yeah. So look, define fij. If I equal j, return true, right? If I plus 1 equal j, then we need to return si equal sj, right? Otherwise, we need to return si equal sj and fi plus 1 j minus 1, right? So sometimes we put another check. If I is bigger than j, then we also return return true or false. Index I should not be bigger than j, right? So it should be smaller than j, okay? So we put this si equal sj in the front. That's why is that? Because if this is false, we don't need to continue evaluating it, right? Do you get it?
Yeah.
Why is that? Look, if I'm saying there's a thing A and B. What's A and B? What's the A and B? If putting A and B, true and true, right? I mean,
Yeah.
true and true is true. True and false is false, right? True means means then both needs to be true, am I right? Yeah? Okay, if I am telling you this A is false, do I need to evaluate B?
No.
Because it's false, right? Okay, how about B? How about A or B? Or, what's or?
Any?
One is true, right? Yeah? So if I'm telling you that A is true, do I need to evaluate B? Because it doesn't matter. No matter what B value is, this whole thing is true, right? Do you get it? Yeah? Okay, so that's why we put this in the front, okay? Then we can replace this, yeah? Replace this. And then we don't need this line, okay? So we can say if Fij, then we can do this, okay? But the thing, look, this is actually a recursion and then function calls, and we want to save it. So we can put this in an array, in a two list array, okay? clearest array. Okay, then we don't need to worry about the function calls. Yeah. So then we can, okay, let me erase this bit, okay? So f equals, at the beginning, true. We set it to true for underscore in range n. We basically create for underscore in range n. So this is the two-dimensional array, yeah? N times n array. So it's n times n array. And at the beginning, the values is true for all cases. For all cases. Then we have to, for I in range, in order to compute this f value, we need to iterate the left index from n minus 2 up to 0, okay? And then for j in range I plus 1, yeah? The single character is always a palindrome. And up to n, 1, okay. Then look, Fij equals Si equal Sj, and Fi plus 1, J minus 1, right? Look, yeah? So this is the same thing, but using the iterated. So we are computing the f values using the nested for loop, right? So look, this bit is O(n) squared, obviously, yeah? But we only do it in front of this. So look, this is O(n) squared, this is O(n) squared. 2 O(n) squared is still O(n) squared, right? So because look, we are optimizing it. Look, the key point today is what? This check takes O(n) time. And then what we are pre-computing it. We pre-computing it, put it in the F array for lookup. Yeah, so the time complexity, overall time complexity is O(n) squared, and the space complexity is O(n) squared. We're using that. And there are many other ways of doing this, yes? And we're going to talk about in the next few lessons, but this is one of the, most straightforward way, right? What have you learned so far today? Come on.
About
How do we optimize this from O(n) cubic to O(n) squared? Come on.
Top down.
Yeah, so which part, this O(n) cubic, which part we can optimize?
The red circle.
Yeah, what is this doing?
Reversing it.
What is it checking?
If it's a palindrome.
Yeah, but this is checking in a real time, it takes O(n) time, right? Yeah, and then what are we doing here?
With cache.
Yeah, we are calculating, we store this, we basically store Fij, right? Look, what's Fij? Is the substring. We want to know if the substring from index I to j, if it's a palindrome, right? So then we pre-calculating it and put it in a cache, put it in the table, right? So why can we do this in O(n) squared? Because we're using the dynamic programming. Look, Fij is based on Fi plus 1, j minus 1, right? So we are reusing it. Look at this part, right? Right, so why we can do this in O(n) squared? Look, we want to find out the index from the substring from index I to index j if it's a palindrome, right? We are not calculating it every time. Instead, we just check one more thing, which is index I equal index j.
Yeah.
And then
Yeah.
based on this.
Yeah.
Do you get it?
Yeah.
Look at this one. We want to check this whole thing if it's a palindrome, right? Look,
Yeah.
this whole thing. Now first of all we check what? This A needs to be equal to this A, right? If it's equal, then we compare. We want to check this is a palindrome, but this has been calculated before, so we don't need to over calculate it again, right? Yeah.
Yeah.
Okay, that's it for today. Bye bye. Bye bye.